So we're going to throw out box and unbox and setbox and just have set bang. We'll keep begin so that we can sequence stateful expressions. So for example, we want let b0 begin, set b10, return b to be a valid program, and return 10, since set is now one of the forms in our curly language. To do this, we're going to need to change interp. It's going to still have the same signature. We don't have boxes anymore, but we still have expressions, we still have environments, we still have a store, and results still need to be produced that have a value paired with a store. And if we look at a program like just evaluate the expression 5, then the result is still 5 in the empty store. This particular example doesn't need to change at all. But let's look at another example. Let x be 5 in x. Again, we should get 5 as the result here, and that would be the end of the story if before we had variables. But now our interpreter will need to allocate a location to store this variable x, just in case there's a set bang later. So if it's going to allocate a variable, that means the result store here is not empty anymore. It needs to have something allocated in it, and since x is the only thing we allocate, that's going to be at address 1, and we'll put the 5 there. So the full test case is this, where we have num v5 as the result, but also along the way 5 was allocated, or x was allocated with the value 5 at cell 1. Let's look at another example. Suppose we interpret the program that's just x. If we start with an empty environment, this is a boring test because it'll raise an exception, but we can put x in the environment, and then we can have this test produce whatever value we bind x to. We've changed our environment representation, so it maps symbols to not values anymore, but to locations. So that means that when we start off a program with an environment that binds x, we will need to also start out with a location in the store. So we'll bind x to location 1, and then in that location we put some value. And depending on what value we choose to put here, say the number 5, then that's the value that we'll get out at the end. Just evaluating an expression doesn't change the store. It doesn't need to allocate when you use a variable, only when you bind a variable. So our store will be unchanged in this example. Let's look at one more. Here we have a function call on an immediate function. Right, so this is left lambda. It means call this function lambda x, add x to itself, and we give it the argument 8. And we can start out with an empty environment and store as we normally do, because this is a program that will run all by itself. If we do that, clearly we're expecting to get 16 as the answer here, because 8 plus 8 is 16. But what happens to the store? Do we have any variable bindings that take place along the way? And we do. 8 is, x is bound to 8. So in the process of doing the application, we will need to allocate a location for x and put 8 as the value in that location. And that's the only variable that we have in the program, so that's going to be our final store, just mapping location 1 to the value 8. All of this is analogous, again, to if we have a function applied to box of 8, and then we have unboxes in the body. This box is the one that application now will be responsible for allocating. Right? So in our old program with boxes and unboxes, if this were the program, we would get the same kind of store out as the final answer. We just need to make that happen with using variables instead of boxes.